Hello Year 5, so here are your answers for today's arithmetic questions. Again, I've posted a really short video, it's about 4 minutes, that should have helped you unpick the learning linked to fractions, because we're moving forward a little bit looking at improper fractions again. So if you haven't watched that yet, it would be really handy if you stopped that and went back to your portfolio page and watched that short video. Ideally you've watched it before you've had a go at the questions, but if you haven't, if you missed that message, then please go back and do it. Okay, so the first question today is a fraction question. It's taken that learning from Monday and what you practiced yesterday a little bit further on. So we've got 2 4/5, add 3 2/5. So again, we've got fractions that include wholes and parts of wholes, but we're really lucky that the denominators, the bottom numbers, are the same, which makes it far less complicated. So again, what I'd encourage you to do, if you're still getting to grips with fractions and you might find them slightly confusing, I would get you to draw something to represent the fractions. So we've got here 2 wholes, okay, and then we need to represent 4/5. So we can see our empty set here, we've got to colour in 4 parts out of the 5, and that then represents that fraction. Okay, so 2 4/5, 2 wholes and 4/5. Then we've got 3 wholes, okay, and then we've got 2/5. Now we would do the same that we did on Monday. We would add the wholes together first of all, okay, the whole fractions that we've got. That's the easiest thing. 2 add 3 is 5. We can check over here and make sure that we're happy with that. We've got 5 wholes. Now this is where it's slightly more complicated, and hopefully the video, I'm going to take that back and use a different colour pen. Hopefully the video helped you before, so I'm not going to go into too much detail. We know the denominator stays the same. Both fractions, okay, in the question, need 5 parts to make a whole. So in one we've got 4 parts, in the other one we've got 2 parts that are left over from the wholes. So 4 add 2 is 6. And I've done that by adding 4 to the 2, and I can also count up the ones we've coloured in purple. It makes 6. Now what we need to do is to make 6/5, remove it from being an improper fraction, okay, and we need to express it as wholes and part wholes, okay. So we've got 5 over here. I can't add 5 and 6/5 because they contradict each other. One is dealing with just wholes and the other one is dealing with improper fractions where the top number is bigger, okay, so we need to have both the same. So we're thinking in order to have a whole with 6/5 we need 5 parts. So in 6 I can get one lot of 5, okay, so that 1 represents 5 over 5, and then I've got 1/5 left over, okay. So if I was looking at this, what I could do, just to represent it to you, is rub out one of those and put that over there, okay, and say that that makes 1 whole, and then I've got 1 left over there, okay. So now I've got to think about what does 1 and 1/5 and 5 add together. So 5 add 1 is 6, and then we've still got that 1/5 left over. And again, if we look at our diagram, we've got 1, 2, 3, 4, 5, 6 wholes, and then 1/5 left over. Okay, right, subtraction. So I was kind to you at the beginning of the week. We've gone back to now having to do some subtraction work because it's really good to practice it, okay? So if we're looking at this, this is our bar model to represent what we know. So we've got a number, okay, subtract another number, leaves us with 690.99, okay? So I know that this is the biggest number, okay, because I'm taking something away from it and then I'm left with that part there. Now these two numbers are not that far away. We'll look at that in a moment. Okay, my question mark is over here. So most of you, I would have thought, will have just done a column subtraction sum, which is fine. So 8 subtract 9. We cannot do that. Remember, you can't swap them over. So I'm going to exchange from this column. I'm going to change that to an 8. Okay, and now it's 18 subtract 9. Now I know 9 and 9 is 18, so 18 subtract 9 must be 9. And then I've got 8 subtract 9. Okay, so this is slightly more problematic because we can only borrow from the column moving up, and there's a 0 there. Okay, so I need to exchange from this column. Like, remember, you can only exchange between one column at a time. So that one lot of 10 that I've borrowed, I'm going to put it over here to make it 10. Now I need to then change that to a 9 and exchange it so that I can bring it over to this column. Now I can complete my calculation. So 18 subtract 9 is the same as what we've just done, so it's 9. 9 subtract 0, easiest thing you'll be asked all day. Then I've got 1 subtract 9. Again, I can't switch it over, so I need to change this and exchange it to a 6. or I need to exchange and change it to a 6 is the way I should have said it. And then 11 take away 9. Now if I count up from 9 to 11, it's a difference of 2, so that's easy there. Okay, and then 6 take away 6 is 0. You don't need to put that in, but there it shows that the calculation is finished. So the answer is 29.99. Now, what I was alluding to or talking about earlier is that these numbers are not very far away from each other, and when I look at the decimals, they are actually almost whole numbers. So I'm just thinking, can I have done that in my head a little bit easier? Okay, so I'm thinking from 690.99, I'm jumping up to, sorry if that keeps coming up, to 720.98. So I'm thinking about, with each jump, I'm going to go to an easier number to work from, and then I should be able to calculate. So what am I adding to 690.99 to get to 691? Remember, that's the very next whole number. So I'm dealing with hundredths. I've got 99 hundredths. How many hundredths do I need to make a whole number? Hopefully your answer is 100. So I need to put my 0 point, and then I'm thinking about 100. So I need 1 in my hundredth column. So it's 0.01. Okay, that is a jump of 0.01. Then from 691, I'm going to jump up to 700. Okay, so I'm thinking about what do I add to 1? Because I've got 690. The next lot of 10 is 700. So I've got 1 here. If I add 9 to 1, I get to the next lot of 10, which from 690 is 700. Okay, then I'm going to come underneath here. Actually, I can go over there. From 700 to the end of the number line is a difference of 20. Okay, 0.98. So much easier with a pen, but never mind. Okay, so now all I need to do is to add my jumps together. So 20.98, okay, add 9 is 29.98. And then add the 0.01, it says 29.99, which matches that answer. Now, I could have done that in my head. I'm really good at picturing numbers in my head and jumping up to more useful numbers. For lots of you, this will be where you feel safest. For some of you, you would have been able to do it in your head. I still would have checked it with a calculation. But for others of you, you could have just drawn a number line and then you'd have the numbers there to help you calculate at the end. Okay, so just some different ways of accessing that question. Okay, it's really good to keep practicing this because I'm seeing that some of you are still making mistakes with it. It would be interesting. I'm asking lots of you about where you think you're making the mistake, and it's why it's so important to be watching these videos. So my first job is to put my decimal point in and to make sure it lines up with the decimal point in the number that I'm calculating with. Okay, so I'm thinking about 8 multiplied by 5. Again, you can use your 5 times table. So I'm not expecting you all to know your 8 times table. Very few of you know that. So if I'm thinking about 5 times 8, I know that that is 40. Okay, so I'm going to put my 0 there, and I'm going to carry this one over here. Again, it reads as 40. If I did it the other way around, it would be 0,4. Okay, 8 times nothing, 8 times 0. If you've got a million lots of nothing or 0, you've still got nothing. So we just have the 4 that we carried over. Now 8 times 5, which we know is 40. Okay, and then 8 times 0 again. See a pattern forming here, and then 8 times 5 is the last calculation we're doing. So this time I'm not going to carry over to the next column, I'm just going to complete it there. So the answer is 4040.4. You can say 0.40, but that 0 doesn't really do anything there. Right. Now, on Monday, I shared a star with you, and I left a secret message that only, well, thus far, because I'm filming this on Monday, 3 people have shown me that they've been watching these videos. And the code word on Monday was Apple. And Alex and Tia and Mia were the only ones so far that have sent Apple to me and received 10 extra dojo points. So I'm going to do this again today. So the code word today is, let's come up with cheese. I don't know why it's cheese, but it is. So if you send me the word cheese on any of your work today, so that might be sending back your arithmetic, you write it as a comment, or it could be on another piece of work, then you will get 15 dojo points. Okay, please do not tell your friends. I'm just doing this as a bit of a test to see who is actually watching these videos. So yeah, if you pass it on, I will not be very happy because I just want to do it as a bit of an experiment just to see who is watching them. So message the word cheese to me and 15 dojo points will be coming your way. Okay, so this was what I was looking at in the in the video this morning. Okay, so we've got an improper fraction that we know is where the top number, the numerator, is bigger than the bottom number. It's still a fraction. You can still put that as an answer. You'll probably get the mark, so don't panic about that. However, the next step for you in terms of your fraction understanding is to be able to convert, so change improper fractions to whole numbers and part wholes. So we're thinking here that we need to divide 37 by 4. So how many lots of 4 can we get out of 37? Now, again, lots of you don't know your 4 times table, which is why I keep going on and on about how it's important, because this would be much easier if you did. However, 10 times 4 is 40, so that is a really good place to start. Rather than counting up in 4s, try and get as close to it as you can with a number fact that you know. So 10 times 4 is 40. So if I take away 4 from 40, I get to 36. So that's 9 lots of 4. So 36 is less than 37. It's quite close to it. So I know 9 times 4, okay, is 36. So I've got 9 wholes. I've then got 1 left over, because 36 add the 1 is 37, and then my denominator stays the same. So 37 over 4 is the same as 9 1/4. Okay, so moving on to these on the other side of the board. I set these again just to get you practicing adding numbers together that are bigger. So all we have to do is 9 add 8 add 7. So there will be lots of different ways that you could do this. I'm going to think about 9 add 8. So 9 add 1 is 10. Okay, so if I take that 1 away from there, I'm left with 7. So that would be 17. So 9 add the 1 from the 8 is 10. I've got 7 left over, so it's 17. So I've got, think about this, I've got 17. Okay, and then I need to add 7. So 7 add the 7 is 14. And then add the 10 is 24. Okay, so just to remind you where I got that. So 9 add the 8 is 17. Now I need to add the 7, and I'm going to break up my 17 there and just focus on that 7 and do 7 add that 7 is 14. Then I'm going to add that 10 back on. Now I know 9 add 8 add 7 is 24, because that's what I've just done there. So 24 add the 2 is 26. Okay, I go back to it. 9 add 8 add 7. We've done it there. It's 24. Add the 2 is 26. So your answer is 2,664. Okay, subtraction, probably with at least one lot of exchanging. I'm going to put that decimal point in straight away so I don't forget it. Okay, 2 subtract 5. You can't swap it over. Just going to double check that my numbers match. Yep. Okay, so I'm going to exchange from the 10th column. And now I've got 12 hundredths, okay, subtract 5, but I can think about it now as 12 subtract 5, which is 7, okay. 5 add 5 is 10, add another 2, gives me the 7 there. 2 subtract nothing, okay, stays as 2. 1 subtract 1 is 0, okay. If I've got 1 and I take that 1 away, I'm left with nothing. 2 subtract 3, this is where I need to exchange again. Okay, and then I've got to do 12 subtract 3. So 12 take away 2 takes me back to 10. I need to take away 1 more, so I'm on 9. Okay, 0 take away 0, there's nothing there, would be 0. You can put that 0 in if you want to. So if you've got the answer 090.27, that's right, but I would write it as 90.27. Okay, 512 divided by 2. Now when you were looking at this, I would presume that you had no problem dividing the 2 by 2. So when we divide by 2, we're halving it, so half of 2 is 1. Okay, I'm thinking about this now as 10. Thinking what is half of 10? It's 5. Okay, remember when we're doing it like this, we need to think about what is each digit worth, not thinking about this as 1, this is 10. Think about which column it's in. So now this is the trickier part. We've got 500. What is half of 500? Can you think about why this is harder than saying half of 2 here? And it's because it's odd. Okay, so the number is odd, so it is harder. Now, when I say it's odd, the digit 5 is odd. The number 500 is even. However, what we'll have to do is go back to our knowledge, if we're stuck with this, of the number 5, and that will help us. So half of 5, and the easiest way for me to explain how to halve an odd number is to think about the even number that comes right before it. So the even number that comes before 5 is 4. So half of 4 is 2. And then we've got 1 left over. So I'm thinking about 5 being the same as 4 plus 1. Okay, half of 4 is 2. And then we've got to think about what is half of 1. So half of 1 is half, people would say. We would write that as 0.5. That is one of the biggest things I've been teaching since, that I've tried to get children to know since I've been teaching, is what is half of 1. Okay, so half of 1 is 0.5. Okay, so half of 5 is 2.5. So if I know that, then I know half of 50, okay, is 10 times bigger, because 10 times 5 is 50. I've made that 10 times bigger. My answer will be 10 times bigger, so it's 25. So that will then help me with half of 500, which is another 10 times bigger, would be 250. Okay, so all I have to do is to add those numbers together, so it would be 256. Right, I'm going to think about UDC for this one. So hopefully you had a go at it, or at the very least do the bits that I'm looking at now. So I'm just going to change my colour. Okay, so a recipe asks, let's get rid of that. A recipe asks for 1/4 kilogram of chocolate chips. B puts in 300 grams. How many grams does she need to take out? Now, whether you could read what that name is, okay, it doesn't matter. So lots of people end up giving up because they can't read the name. However, so long as you know that it is a person, it doesn't matter whether it's a girl or a boy, okay, you know that that is a name because it starts with a capital letter, okay, it's in the middle of the sentence, so it's only proper nouns to start with a capital letter. So there is a person that is making a recipe that involves 1/4 kilogram, okay, it doesn't matter that it's chocolate chips, okay, she puts in 300 grams. How many grams does she need to take out? So we need to think about what is the knowledge we need to help us with this. And it is, how many grams are there in a kilogram? Okay, so when you hear the word kilo, okay, or kilo, we're thinking about 1,000. So there's 1,000 meters in a kilometer, and there's 1,000 grams, okay, in a kilogram. So we've got to now divide 1,000 by 4, because we're finding 1/4, which is the same as dividing by 4. Okay, so the best way and the fastest way to do this is to half it and half it again. Okay, if we half it once, we're dividing by 2. If we half that again, we're dividing by 4. So half, and interestingly, it fits with what we've just done, half of 1,000 is 500, okay, and then half of 500 is 250, which is what we've looked at. So the recipe asks for 250 grams. She's put in 300 grams, okay. So what I'm going to do is my drawing part. So I'm going to you don't really actually have to draw very much for this. So that is how much is needed in the recipe. Okay. And then she's put in 300 grams. Okay. And I'm just going to use different colour. So that is how much B is put in. So it's clear because she's put in a number that is bigger, she's put in too many. So it says how many grams does she need to take out? Okay, so we need to think about how do we get back from 300 back to 250. So she needs to take out 50 grams. Okay, because 300 grams take away 50 grams is 250. Happy with that? So the answer is 50 grams. So then the challenge is, what would the amount that B has taken out be in kilograms? So again, we need to use that understanding of there are 1,000 grams in a kilogram. Okay, so I'm thinking about, I need to divide my 50 grams because it's 1,000 times bigger if I want to say it and show it in kilograms. So I need to divide 50, okay, by 100. So I need to now think about this. I'm just trying to think about how I could do this the easiest way so you can see it. So I'm thinking I'm going to take that away. I'm going to think 50 divided by 10 is 5. Yeah, I'm going to have to then think about, I'm going to divide it by 100 now, so it's going to be 0.5. So 50 divided by 10 is 5. 5 divided by 10 is 0.5. So that means I've divided it by 100. I now need to divide it by another 10. So my answer there is 0.05 kilograms. So we know that in 1,000 there are 3 zeros, okay? That shows you that that is how many places you need to move the digits down. So in my 5, I suppose I should put the 0 there because the 5 and the 0 have moved down. So divide it by 10, I've moved it down again to divide by 100, and I've moved it down again to divide it by 1000. So the answer to the challenge is 0.05 kilograms.